Hello guys, Winston here. If you're subscribed to the Carbide 3D channel, then this shouldn't be a surprise to you. It's what I call the Carbide camp knife, and it, along with its three siblings, are among the very first and only knives I've ever made. Today I'd like to take you on sort of a behind-the-scenes look at how I approached this project and some of the things I learned and overcame along the way. Before we go on though, if you haven't seen the CNC knife making series I put out on the Carbide 3D channel yet, I do recommend you go check it out. I'm going to be skimming over a lot of the nitty-gritty stuff here because this video is going to be more of a conceptual discussion. I'll be touching more on things like who or where I look to for information, my stress level throughout the endeavor, and what I got out of it personally. If you want all the in-depth details about the actual tangible process I went through, then check out the 7-part knife series on YouTube. I did my best to focus each video in that series on its own topic, so there's one on 3D modeling the knife, one on machining it, heat treatment, machining G10 handles, and more. Watch whichever ones you want, or preferably watch them all. I'll have the playlist linked anywhere YouTube will let me. If you haven't seen those videos yet, it's not a big deal. There's no spoilers here. It's not like, surprise, I made a knife. But if at any point you see something and you want a more in-depth explanation, you know where to find it. So, with that introduction complete, let's take a look back on the Carbide camp knife project. 3 months ago, I set out to make my own knife knowing basically nothing about the subject except for what I'd seen on YouTube from people like Alex Steele and the Man-at-Arms series. I also knew that CNC knife making was a thing through people like John Grimsmo, but my overall exposure to the subject was minimal at best. When my boss Robert threw out this project idea sort of as a challenge, I was extra motivated by the fact that I knew I was going backpacking later this year. A camp knife, especially one that I'd designed myself, seemed like a really cool thing to be able to bring with me. So I really wanted to make this knife even though I was wildly unprepared. The first thing I did was start sketching and cutting out cardboard mock-ups. A camp knife is a deeply practical implement. It's got to be comfortable, ergonomic, and effective. So I iterated until I got to a design that I liked. Throughout this process, I was also learning about knife terminology, and if you think it looked like I tried to throw in every design element I could from this annotated picture, well, then you're absolutely correct because I am a foolish completionist. But once I had a design established, I needed to face some more concrete decisions, namely what kind of steel to use. And this is one point where I started deep diving the channel of Aaron Gough, an experienced knife maker with a no-nonsense channel chock full of solid information and direct delivery. He's experimented not only with a bunch of different steels, but also finishing techniques, fastening methods, and more, so his channel was a wealth of information for me. I was really tempted to use the same steel he predominantly uses, which is A2 tool steel. This is an air-quenching steel, which means that instead of heating up a blade and quenching it in oil to harden it, you heat it up and then just let it cool down through natural convection. It's an awesome process that you can perform with the blade sealed in an oxygen-free environment, which means you'll have almost no scale or discoloration on the blade afterward. But looking at the equipment I had at my disposal and noting my distinct lack of access to a heat treating oven or vacuum furnace, going with A2 would have meant having to send out my blades for heat treatment. I wasn't deterred by the cost, but with how uncertain I was about my project schedule given my large knowledge gaps, I wasn't sure I could afford for my knives to be in transit for a week or two. 1095 was next on my list, but JPL Richard convinced me to go with 01 tool steel instead. It's a pretty agreeable alloy that's relatively forgiving with respect to heat treatment, and it seemed like a good fit for a beginner like me. Now, while that sounds like a pretty straightforward decision tree, it was at times an illogical, obsession-driven process of counter-reasoning. I don't know how your brain works, but I can sometimes get hung up on specs or comparing features on paper. A2 is a little more corrosion resistant. The air quenching process would result in less cleanup as well. It seemed like it would result in a technically superior end product, and I just couldn't let that go easily. I'm the same way when shopping for cars or gadgets on Amazon or CNCs, but at some point you have to shut up, draw a line in the sand, and decide what you're going to do. I spent about 72 hours going back and forth about whether or not I could actually pull off an A2 blade and afford to send it off for heat treatment. At the end of the day though, losing control of an important part of this project to an out-of-house vendor would have left this story incomplete. This was my chance to push myself out of my comfort zone and learn something new. So I went with a steel that would pose fewer schedule complications and make for a better video, instead of the more exotic alloy with properties I really wanted. With the material determination made, I called up Ed Ford to request waterjet time, which he graciously provided. Not like he had a choice though, since this would be a Carbide 3D sanctioned project. Now, if you looked at the footage closely, you'll notice that the first couple knife blanks that Edward cut didn't seem to match what I modeled. I'm not sure what it is about the SVG file format that makes them so error-prone, but if you've ever opened up a file in Inkscape or Carbide Create and the arcs are all reversed, concave becoming convex or vice versa, that's what happened here. And I didn't want to bother Ed to shoot new footage with the next batch of blades, so all I had were videos of the original botched blades being waterjet. With the corrected knife blanks in hand, I now had to figure out how to work hold them properly. Again, Aaron Gough has an excellent video showing his workflow, and seeing how well he had a process dialed in really inspired me to put the time into designing a fixture with stations for my knife. When you can move stock through your CNC assembly line style and not have to worry about precision because it's already built into your fixture, that's an incredible burden lifted from the operator, and it makes things way more efficient. Viewers of episode 3 will know that I ran into a lot of chatter-related issues in the machining phase of this project. Small diameter tooling, a desktop CNC at the limits of its rigidity, suboptimal tool pads. It was never going to be easy, but I was really humbled by the fact that even when I was on my 4th blade, I still hadn't nailed down the perfect recipe. All of my blades had gouges of varying severity between the choil and plunge line. It wasn't until several days after machining that new tool pathing approaches dawned on me. Like, for example, using boring operations to profile the jimping and choil instead of hoping that my small contouring stepovers would quell the small chirps I got when the end mill dipped into the recesses. Or using an adaptive toolpath like a 3D contour finishing strategy instead of, an actual 3D contour, because feed optimization is not the right approach for trying to get through high cutter engagement corners. I feel like if I had just one more knife blank now, I could get it perfect this time. And then when it came time to hand finish these blades, I initially wanted to try to sand these smooth like a traditional knife, but it ended up being such a tedious process that I decided that 2 of the knives would sport a raw machined look, which is actually fine by me because I thought it looked pretty cool. Recently though, someone on Instagram pointed me at Prince Customs, and they employ CNC knife making techniques that are like next level compared to what I can do. Their creations are truly art, and it opened the creative floodgates in my brain. I suddenly had so many design ideas I wanted to try after seeing his work. What if I used a radial finishing toolpath on the bevels, or overlaid custom vectors like my logo and traced them into the face of the knife as a pattern? Sadly, it was too late for me this time around, as this revelation was after I was locked into the knife design you see here. August 9th was my personal D-Day, the day of heat treatment. There were so many things I'd learned that I had to put into practice that it was honestly a little overwhelming. First off, I've never used or lit a forge before, so I didn't know quite how much gas I ought to be giving it. Initially, it wasn't enough as it was taking way too long to get my test pieces up to temperature. I also had no idea if I had a reducing flame coming out of my burner, which is when you run slightly fuel rich. The combustion process ends up consuming all the available oxygen, making it more inert for the steel inside the forge. But with how bright it was outside, I could barely see a flame, so I really couldn't gauge the fuel-air mixture very well. My adjustment to the air inlet was a bit of a guess. Then there was the issue of not having an infrared thermometer that could read 1400 plus degrees Fahrenheit, nor did I have an appropriate thermocouple. I had to gauge the temperature of the steel by eye. Online charts were really helpful in establishing the exact shade of red I was looking for, but my judgment of color had never been tested like this before. And then, on top of it all, Rob had his son come to work who had made an old 1095 blade on a belt sander many months ago when knife making seemed like a captivating idea to a young mind. If I screwed up one of my own blades, I wouldn't have felt so bad, but now I'm responsible for someone else's knife made from a steel I hadn't done much research on, and I have the pressure of a live audience member that also periodically walks in front of my camera. And my backpacking trip was in 6 days. At this do-or-die juncture, I had no choice but to trust that I had enough knowledge to figure it out as I went. If countless hours of YouTube hadn't adequately prepared me for this moment, it wouldn't mean the internet had failed me, it would mean that I had failed the internet. And lo and behold, I emerged from this day with hardened steel. The next few days went by in a blur as I was working late nights in the garage to get everything done. I had to temper the blades, machine G10 handles, fit them to the blades which I'd scrubbed and sanded, apply some epoxy, install Corby bolts, Dremel off the heads of the bolts, sand them flush, discover the threaded holes in the bolts went deeper than I expected, finish sanding everything to fit, and then my progress was stalled by another unfamiliar process, making a Kydex sheath. This step concerned me mainly because it didn't involve a CNC, but under the expert internet tutelage of Mr. Gough, I made a really basic sheath. I had also been hoping to integrate a belt loop as well with this design, but I didn't have any nylon webbing, nor did I have easy access to my sewing machine, so I couldn't fully emulate Aaron's design. But the beauty of the internet is that you can very easily find more than one way to sheath a knife. Enter Walter Sorrells, another prominent sharer of knife knowledge on YouTube with a different sheath design that allows for an integrated belt clip. Furthermore, the minimum bend radius of Kydex means that you can form a really natural drainage hole for any retained water, a feature that Gough had to add in manually. There are aspects of both designs I like a lot, like the single-piece Kydex thing Sorrells had going on, but I would also prefer an option to remove the belt clip because, let's be honest, I don't think I'll be wearing a knife like this all that often, if ever. So, again, if I had just one more knife to make, I'd love to try something different. And this is exactly why we have to go through the motions of making. You can't iterate and improve without doing. There's no replacement for action. At the end of the day, I'm really glad I went through this experience. I managed to wrap up the Carbide camp knife project in time for my backpacking trip, and being able to bring this story full circle is one of the proudest moments in my maker career. I conceived, designed, and brought to life one of the most fundamental tools in outdoor recreation. And the knife works surprisingly well for being made by someone with no prior knife making experience. It handles food prep with ease, it'll cut paper and junk mail and paracord, and it's tough enough for at least a little bit of abuse. Hold up, that looked lame, do it again. Better. Despite the overall success though, the gears in my head are already turning for a Carbide Camp Knife Mark II. If I were to hypothetically produce a second batch of knives, the first thing I would tackle is weight reduction. I carried this knife 12 miles through a desert each way. Every gram matters to me now. Next time, I'll skip the stainless steel Corby bolts and go for aluminum. The steel in the knife handle will be thinned out because after this first bolt, I really don't expect much flex in the handle. I'll also narrow the blade because in hindsight, the original looks a little bit chunky. I'll remove some additional material outside the handle, rounding it over some more. The same handle profile will be retained because I like the feel of it and so I can reuse the machining fixtures. The profile of the plunge lines for the primary bevel will be widened to ease the transition of the cam tool pads into that corner. The top edge of the plunge line will also no longer have a vertical constraint. I have no idea why I did that, but it made sanding the blades kind of annoying because that edge caught my sanding block repeatedly. The swedge will be removed entirely. The complexity it adds to finishing isn't really worth it. The minimal material reduction it added will be compensated for by having bevels that push further up the face of the blade. In terms of process improvements, I'd like to finally make that jump to A2 tool steel. Without the time pressures of an impending trip, I can send out the blades for hardening. Heck, maybe I'll even have them do a cryo treatment. I'd also want to have my knife blanks surface ground to final thickness before machining. This way, all I have to do is bore pinholes, profile the blade, and then I can go straight to beveling. I know a guy who could do a small batch for me. That would make the blanks a lot more consistent and save me about 40 minutes per blade. Outsourcing these last two steps would dramatically reduce my time investment in each knife and make it feasible to revisit this project in the future, which I really want to do because this project has made me fall in love with knife making. The final form of the Carbide camp knife was a reflection of my pursuit of utility. But in going through this ordeal, I also began to imagine turning a knife into a canvas for creative expression. Those two aspects of optimization and design make this something I could easily sink days into and enjoy every minute of. So hopefully in the next year or so, you'll see the next evolution of this project taking shape. I want to thank you all very much for watching and putting up with my painfully slow upload schedule for the past 2 months. This project was one of the most technically challenging things I've ever undertaken, but I couldn't be more thrilled with what I've learned along the way. Again, check out the full knife making series on the Carbide 3D channel if you haven't already, and I'll be back soon with more CNC projects and DIY nonsense.